Signal generators are a critical component in the field of electrical measurements. These devices produce electrical signals of various frequencies, waveforms, and amplitudes that are used to test and calibrate electronic equipment, perform research and development, and produce audio and video signals. In this presentation, we will explore the different types of signal generators, their various parameters, and applications in the field of electrical measurements. We will also discuss the factors to consider when choosing a signal generator for a particular application. Signal generators can be classified into different types based on the waveform they produce or the frequency range they cover. The most commonly used types of signal generators are function generators, which are versatile and commonly used. They produce waveforms of different shapes such as sine, square, triangle, and sawtooth waves. These are often used in laboratory experiments, testing electronic circuits, and audio signal generation. The working principle involves a voltage-controlled oscillator circuit that generates a signal which is then fed into a shaping circuit to produce the desired waveform. Arbitrary waveform generators are capable of generating waveforms with any shape defined by a user. These generators offer a high degree of customization and precision, making them suitable for research and development applications. Pulse generators produce pulses of various shapes and durations, commonly used in digital circuits and microprocessor-based systems. RF signal generators produce high-frequency signals, typically in the range of 10 MHz to several GHz, used to test and calibrate communication systems, radio and television equipment, and radar systems. Each type of signal generator has its own set of advantages and disadvantages. Function generators are cost-effective and versatile but may lack precision for some applications. Arbitrary waveform generators offer high precision and customization but can be complex to operate. Pulse generators are precise but limited in frequency range. RF signal generators are essential for high-frequency applications but can be expensive and require additional equipment for proper operation. Signal generators have various parameters that can be adjusted to control the output waveform. These parameters include frequency, amplitude, and waveform type. Frequency is measured in hertz and determines the number of cycles per second. Amplitude is the peak-to-peak voltage of the waveform. The waveform type determines the shape of the output waveform, such as sine, square, triangle, and sawtooth waves. Understanding these parameters is important for selecting the appropriate signal generator for accurate measurements. Additional parameters to consider include duty cycle, modulation, and sweep. The duty cycle is the percentage of time a pulse is on during one cycle. Modulation involves varying one or more parameters of the output waveform, such as amplitude or frequency. Sweep refers to varying the frequency or amplitude over a defined range. These parameters can be adjusted manually or automatically. Understanding these parameters is essential for selecting the appropriate signal generator for specific applications. Signal generators have a wide range of applications in various fields such as telecommunications, electronics, physics, and engineering. They are used extensively for testing and calibration of electronic and electrical devices. For instance, a signal generator can be used to verify the frequency response of an audio amplifier or to calibrate a spectrum analyzer. They are also used in research and development to generate various waveforms for studying the behavior of electronic circuits, materials, and devices under different conditions. Signal generators are used in communication systems for generating modulated signals such as AM, FM, and PM. They are also used in educational institutions to teach students about electrical measurements and telecommunications. In production testing, signal generators ensure that electronic devices meet the required specifications. They are an essential tool in electrical measurements, providing a precise and controlled source of electrical signals for testing and calibration.